This is Leo. Today we're going to tackle another Leetcode problem, which is the largest rectangle in histogram. So now let's read it. Given an array of integers heights representing the histogram's bar height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. So let's take a look at the example. 2, 1, 5, 6, 2, 3. So this 2 element could only go all the way to the first index. So the maximum area it can create is just this 2. Okay? So let's see the second element. This 1 goes all the way left to 2, to index 0, and to all the way to the index 5. So the total width would be 6. And the height is 1, so the max area of this index is 6. So how do we tackle this problem? I think it would be easier if we can use a stack to record everything that goes back. So let's take a look at the example. In this case, we're going to go from left to right, and we're going to find the drop in the number here. So once we find a drop, we know that this 2 will never go to the right. Okay? So, in this case, we pop this from the stack and we'll calculate how far it can go back to the left. So, now this is the maximum area this can make. Alright? So, if we form this monotonic stack, we will only have this 1, 5, 6 ascending order in the stack. Once we hit something like this, we find a drop here. We're going to pop this out and calculate the width with the height and update the maximum area. Okay? So once we got no drop here, once we reach the end of the stack, we will have something like this left. So and at this time, we'll all go all the way back to the left to see how far it can go from the rightmost end. Okay? So once this is done, we can initialize everything. So first, we're going to return an integer, and we're going to call it max area. We initialize it to 0. So obviously, we're going to return it at the end of this algorithm. Okay? So as I said, we will initialize a stack. So I will use a deck to initialize it. So it's going to be a new array deck. Okay. So for Sentinel, for us to be able to reach all the way back to the leftmost end, I will push something inside, and I will add a -1 as a sentinel number. So for the purpose of convenience, we're going to initialize the length of the array to a variable called len. Okay, so first we're going to initialize everything from the stack. So for int I equals to 0 and I is less than length, I plus plus. If nothing happens, we just keep pushing it into the stack. Okay? But once we've identified a drop in the number, and it should not be the first element, which is -1. So once the stack.peak is not -1, and the heights, what are we talking about? We will look at this one, right? So it's stack.peak. Once it is larger than or equal to the current element we're processing, so this will be heights 1. In this case, we're going to initialize the current height, and it will be heights stack.pop. We pop the last element out, and we're going to calculate the current width it can go. So obviously the right boundary is the I, and the left boundary should be the stack.peak. In this case, it's the 5, right? So also we have to subtract a 1 because we added a -1 to the first. Okay, once this is done, we can update the max area, which is the math.max. And we're going to use the current height to time the current width. Okay, so that should do it. Okay, once this is done, we should have something left in the stack. So we have to make sure that the stack is empty. So while the stack.peak isn't -1, in this case, we're still doing the same stuff. So current height equals to heights stack.pop, okay? And current width. So since now we reached the end of the array, we're going to use the length, which is the number of the last index, the length to subtract the stack.peak to see how far it can go back to the left, and subtract 1. So we're also going to update the max area in this step. And when this is processed, everything's now cleared in the stack. We can return the max area, which will give us the right answer. So let's see if it's right. Okay, I think it should pass. So for the complexity analysis, we use the stack. So the space complexity will be O of n, where n is the number of the elements in the array. And for the time complexity, since we're processing each element, so that it's a linear algorithm. So let's see if it works. All right, it passed. So yeah, thanks for watching. It'll create everything today. Bye bye.